Okay, stick with me on this one because it's a little tricky in terms of keeping track of what you know. Um, Let me write out the formula. Okay, area is equal to 1/2 the apothem times the perimeter. And there's a couple of things going on here. One, we know that the perimeter is really equal to the length of a side times the number of sides. Okay, there are 6 sides, so I'm going to put a 6 there, times whatever the side length is on each one. So that's an S. Okay, and I'm going to simplify this down by also, oh, and I can write in 50 because they gave us the area is 50. Okay, so we have all these pieces of information. And I'm going to simplify it a little bit by saying 50 is equal to, what's 1/2 of 6? 3. So that's like 3 times A times the side length. Now, if we want to know the side length, the first thing we're going to need to do is find the apothem. Check out what's going on here. I'm going to draw the hexagon. And in fact, yeah, let me just draw it out. Okay. Yeah, I know it's a little sloppy, but I think you'll be able to manage your feelings about my terrible hexagon. Anyway, now let's take one of these sections of it. Okay, if we go from the center here, there, we've got a 60-degree angle up there. Okay, you should know that when you divide a hexagon up into the 6 triangles, then you've got 60 and 60 and 60. It's equilateral triangles. That's what hexagons uh, are composed of when you connect the center to all the vertices. Okay. Now, in order to calculate this, we need to find the apothem. So what we need to find is this length right here in green. Okay, and when we do that, you hopefully can see that that 60-degree angle that I just took away there is replaced by 30-degree angles, right? And of course, the apothem forms a right triangle down there. So now what we've got is we've got this 30, 60, 90 triangle that essentially is this. This is like a section of my drawing down there. You can see that's this. Now let's fill in the numbers we know. That's 30, that's 60, and got a right angle there for 90. So what's the length of a side? Well, look on this main hexagon over here. That has length S, standing for side. We don't know what it measures. I'm going to write it in as side length S. But we do know that whatever this is, that's half of S. Because the whole thing's S, then that's S really divided by 2. That's another way to write it. So we could call this side S divided by 2. And of course, that's the short leg of a 30, 60, 90 triangle. So what does the long leg measure? The long leg measures S divided by 2 times square root of 3. That's what the apothem of our hexagon measures. S divided by 2, meaning half of the full side, gives us that short side, that short leg of this, times root 3. S divided by 2 times root 3. And I'm going to replace the apothem with that. So let me just erase this drawing here. And we're going to replace the apothem with S over 2 divided by, or times square root of 3. Okay, and then let's fill in the rest. 50 equals 3 times S over 2 times root 3 times S again. Okay, interesting. So let's combine all of the numbers that we've got. Okay, everything, these are all, you can imagine that these are all over 1, right? Over 1, over 1, over 1. Everything's over 1 if it's not there. Okay, so if we multiply that all together and juggle the numbers around, we get 50 is equal to 3 times root 3 times s. Here's 3 times root 3, and here's s, and here's s, or s squared. 3 root 3 times s squared. And that's that whole thing divided by 2. So I'm going to multiply both sides by 2. I'm going to say 100 is equal to 3 root 3 times s squared. I just took what was on the bottom, divided by 2, and I multiplied both sides by 2. Now what's the last thing that we need to do here? Well, one of the last steps is we need to divide both sides by square root of 3. I'm sorry, 3 square root of 3, because that's the number part of this, 3 root 3. So I'm going to divide both sides by that. I'm going to get 100 divided by 3 root 3 is equal to the side length squared. Yeah, seems complicated, but you can keep track of it if you know what you're doing. All right, and then over here, moving this up here, I'm going to say then, okay, if that's what s squared is, then s is going to be equal to the square root of all of that, 100 divided by 3 root 3. If you calculate that, and I should put approximately equal to, if you calculate all that, 100 divided by 3 root 3, and then square rooted, you get 4.38691, which, because they're asking us to round to the nearest tenth, becomes 4.4. And we're looking for the length of a side. The units are inches, so it's inches. And that's your answer B. But Mr. Massey, that's so hard. Well, you know, sometimes you get really easy problems, but we don't want to always be only able to do the very easiest things, right? You can play Mary Had a Little Lamb on the piano, but if that's all you can do, not very impressive, not taking it very far. We want to be able to go far with all of this, and so we're taking information that we know, and then we're saying, let's apply it to a more complex problem and show that we can actually do it. We can do this. This is where writing down your work comes in handy. So anyway, that's how you do it. You might want to watch that video more than once to really lock in what's going on there. But essentially, I knew that the apothem length on this is based on whatever that side length is. And since we didn't know that, we had to describe the apothem length in terms of the side, right? The whole thing is S, and this is S over 2, or half of S, and then this is half of S root 3. So we can fill that in for the apothem length, and then unwrap it from there. Okay.